Hello guys, welcome back to my channel. Hope you're all good. So guys, this is the second part of NASA's PSYCHE mission to an asteroid. If you have not watched part 1, I recommend you to go and watch part 1.
Just a recap, guys. In part 1, we have covered the following topics. What is PSYCHE asteroid? Where is the PSYCHE asteroid? What is the PSYCHE asteroid made of? How long is a day on PSYCHE? How long is a year on PSYCHE? How far is the PSYCHE asteroid from the Sun? How much does the PSYCHE asteroid weigh? How dense is the PSYCHE asteroid? Does the PSYCHE asteroid have gravity? How big is the PSYCHE asteroid? And how it look? Psyche is the name of an asteroid orbiting the Sun between Mars and Jupiter, and also the name of a NASA space mission to visit that asteroid, which is led by ASU, which is nothing but Arizona State University. What makes this unique is that Psyche is the first mission to a world likely made of largely of metal rather than a rock or ice. Psyche is the 14th mission selected for NASA's Discovery program. Psyche was chosen by NASA on January 4, 2017. So the question comes to our mind, right? What is NASA's Discovery program? Let's have a quick glance. The goal of NASA's Discovery program is to provide frequent flight opportunities for high quality, high value, focused planetary science investigation that can be accomplished under a not to succeed cost cap. By conducting a series of planetary science investigations, NASA will provide a mechanism by which pressing questions in planetary science may be addressed, permitting a steady improvement in our understanding of planetary systems and the processes that affect them. The frequent, steady nature of investigations will ensure a continuing stream of fresh scientific data to the planetary science community, thus helping to maintain the excellence of the US planetary science program and to inspire the next generations of investigators. The Discovery program strives to advance scientific knowledge and exploration of elements of our solar system, add scientific data, maps, and other products to the Planetary Data System Archive, expand the pool of well qualified principal investigators and project managers for implementation of future missions in Discovery, implement technology advancement proven in related programs. The asteroid Psyche may be able to tell us how Earth's core and the cores of other terrestrial planets came to be. These terrestrial planets include Mercury, Venus, Earth, and Mars. Because we cannot see or measure Earth's core directly, the Psyche asteroid may offer a unique window into the violent history of collisions and accelerations that created the terrestrial planets. It is the only known place in our solar system where we can examine directly what may contain metal from the core of a planetesimal. So the question should come into your mind why we cannot see or measure Earth's core directly. This is because the core of the Earth lies at a depth of 3000 kilometers, which is more than 1800 miles. As per our current technology, we have only able to drill around 12 kilometers, that is about 7.5 miles. That is the most our technology allows today. Additionally, Earth's core lies at about 3 million times the pressure of the atmosphere. The temperature of Earth's core is about 5000 degrees Celsius, which is almost equal to 9000 Fahrenheit. So don't even think about going to Earth core, guys. The Psyche mission consists of 6 phases labeled from A to F. These phases span from initial studies and selection of mission by NASA for its discovery program through building and testing of instruments and spacecraft to launch, cruise, and arrival at the asteroid, and finally to orbit and close out the mission. In September 2015, the Psyche mission was selected by NASA to develop a detailed concept study for consideration for NASA's discovery program. Step 1 is the initial proposal stage. The team had been working on the idea since 2011 and submitted a 256-page proposal that was selected for the Phase A concept study. Phase B was more on preliminary design of all instruments and spacecraft. Science and engineering teams on the mission designed the spacecraft and instruments that will be used to analyze the asteroid. Phase C was final design and subsystem fabrication, assembly, and testing. Science and engineering teams begin to build their instruments. These instruments consist of a magnetometer, a multispectral imager, and a gamma ray and a neutron spectrum. Important mission milestones occur in Phase D, which include instrument and spacecraft assembly and testing, shipping the spacecraft to the launch site, and mission launch. Phase E of the mission encompasses cruise. So, cruise is nothing but the activity that occurs between the launch and the encounter with Psyche, including a Mars gravity assist, arriving at the asteroid and orbiting the asteroid. The final phase, phase F, is for mission closeout. In this phase, the mission team provides all remaining deliverables and safely decommission the space flight systems. Once the mission is complete, the spacecraft will stay in orbit around Psyche, like a moon. This is how all NASA's mission end. The Psyche mission has specific science goals and objectives. Science goals includes understanding planet formation, which investigate iron cores as previously unexplored building blocks in planet formation. Examine terrestrial planets, which will gain insights into terrestrial planets' interiors, including Earth. Explore a unique world. For the first time, study a celestial body made of metal. And science objectives include determine composition, whether Psyche is a metallic core or composed of unmetalled material. Access surface ages, determine relative ages of different regions of Psyche surface. Study elemental composition, meaning investigate whether Psyche shares light elements with Earth's high pressure core. Examine formation conditions. Determine if Psyche formed under oxidizing or reducing conditions compared to Earth core. Characterize morphology. Study and characterize the physical features of Psyche. The mission is led by Arizona State University. NASA's Jet Propulsion Laboratory is responsible for mission management, operations, and navigation. The spacecraft's solar electric propulsion chassis will be built by Maxar Technologies with a payload that includes an imager, magnetometer, and a gamma ray and a neutron spectrometer. The mission cost approximately $850 million, which includes mission development, operations, and science. This amount does not include cost for the launch service, which is procured separately. It also don't include the cost for deep space optical communication demonstration hardware or its operations. As I am a newbie, support by liking, sharing, and subscribing. Thank you.